Hello, we're going to be working through this divides debugging problem. So let's go ahead and read the description together. It says here, we decided to write a function that returns true if x divides y and false otherwise. So what does divides mean? Well, it tells us here, x divides y if there is an integer c such that x times c equals y. So another way to write that would be, there is some integer c where when you divide y by x, you can create an integer c, right? And remember, all of these are ints. So the basic idea is y over x should output some integer in order for it to be true. And if we see the doc test, does 2 divide 4? Yes, because that would be 4 over 2, which means c would be equal to the integer 2. But 4 over 2 would be false, because that's 2 over 4, meaning c is like 1/2, which would not be an integer. Okay, cool. And it also tells us it should only accept integer values for both x and y, and your function should raise a type error if any other data type is passed. Tells us our code has some bugs in it, and we need to find at least 3 and explain what they are. There could be bugs in any of the given lines in the body. Okay, cool. So let's see what's going on here. So this is how we want the code to behave, right? If we pass in 0, then we should get this 0 for x here. Then we should return an assertion error that the denominator should be 0. And if we pass in strings, we should be getting a type error, right? You can only pass in integers. So let's step through the actual code line by line, right? First up, we have assert y is not equal to 0. Denominator should not be 0. Well, if we look at our drawing here, we have here that the denominator is x based on this equation. And actually, if you look at the test case here, we pass in this assertion error, denominator should not be 0, when x is equal to 0, right? When this first value is equal to 0. So that tells us that this should not actually be assert y is not equal to 0. This should be x is not equal to 0, since that's actually our denominator. So we could write that as part A. Assert y not equal to 0 should be x not equal to 0. And once again, that's because x is our true denominator, right? So it's okay if it's actually okay if y is 0, but it's not okay if x is 0. Okay, cool. That seems to be one of our bugs. What's next? We have this if statement, and it looks like what this wants to do is say, hey, both of x and y should be integers. Otherwise, we're going to raise this type error. So let's follow the logic that they have here. If type of x, remember type is just going to give you int or string or whatever. If type of x is not equal to int and type of y is not equal to int. Well, remember, what this is going to do is it's going to raise the type error if both x and y are not ints. But we want to raise the type error if any of x and y are ints, or aren't ints, sorry. So that means this and here should actually be an or. Because even if only one of these is not an int, we want to raise the type error because we can't work with it. Both x and y have to be ints. So this should be an or statement instead. Okay, so let's write that. If type x not equal to int line, I'll kind of abbreviate since I explained it, but line should be or, since neither x nor y cannot be ints, right? Even if one of them, so this is going to be skipping the error in the case where x is a string and y is an int, for example. That would not raise this error since not both of them are not ints. Hopefully that makes sense. And finally, we have this return y modulus x is not equal to 0. Okay, well remember, the modulus is going to get us the remainder after division. So we know that a number is evenly divided into another if the modulus is equal to 0, right? Because that means there was no remainder. So the numbers divided imperfectly. But you can see here that we are actually going to be returning if it was not equal to 0. That means that if in the event that y mod x was equal to 0, we would actually return false. Or sorry, yes, we would actually return false. When in reality, we want to return true, right? Because that means that it did divide evenly. So that means instead of having this as a not equal, we want this to be an equals equals, right? We want it to be true when it divides in perfectly, and we want it to be false when it doesn't. This is getting us the inverse behavior. So we will say y mod x, that should be y mod x equals 0. Because we want to return true when remainder is 0. And those are our 3 bugs. I'll label them here. 1, 2, and 3. Okay, great. I hope this was helpful.